Good afternoon, everyone. Sorry for the little delay there, but I think we're ready to get started. So thank you all so much for joining us. We're really excited for today's webinar. This webinar is an encore of our presentation from the Streamlined conference that was a couple weeks ago. And we're thrilled to have Lorena and Carla joining us from Tucson Water to talk about their experience with GIS and HxGN EAM integration. Throughout the presentation, feel free to submit your questions for them using the Q&A feature on the right-hand side of your screen. And with that, I'm going to go ahead and hand it off to Lorena to introduce today's presentation.
Good morning. Welcome to Tucson Water's HxGN EAM to GIS integration. My name is Lorena Castañeda, and I'm a GIS data analyst for Tucson Water. Presenting with me today is Carla Borbon, also a GIS data analyst with Tucson Water, and Umesh Mignon, who is the Vice President of Strategic Product Management for Geonexus. On our agenda today, we will be giving you a small overview of Tucson Water. We'll go over our project background, the solution from Geonexus, our implementation and anticipated benefits, followed by a short demo if time permits, and then we'll open up to questions. With that, I want to hand it over to Carla for an overview of Tucson Water. Carla?
And good afternoon, everyone. Thank you, Lorena. Like Lorena mentioned, we are from Tucson and work at the Tucson Water Department. The slide you see here shows our water service area. Our service area covers over 399 square miles. Here are some of our statistics. We were established in 1900. We serve over 775 customers. We have 206 active production or standby groundwater wells. We have 60 potable storage facilities capable of storing 305 million gallons. We manage over 4,600 miles of pipeline and have hundreds of booster stations and pressure control valves. And with that, I will be passing it back over to Lorena, where she will be talking more about our project background.
Thank you, Carla. A little bit about our project background. In moving to a new asset management database, we knew that some of our data was inconsistent and unreliable for decision making, and our current asset management software was approaching its end of service. So we had two choices, either upgrade our current software or replace the software, but either way, we knew both would require some type of implementation. So change was really inevitable for us. The HxGN EAM implementation was a citywide adoption, which took 18 months to implement. The implementation involves 5 city departments with over 1 million assets. We have 700 end users with both mobile and desktop applications, and over 115 processes were documented. Over 500 meetings and working sessions were held to get this done. On August 8th of 2022, the City of Tucson went live with HxGN EAM in the cloud, sunsetting numerous legacy systems and deploying its solution to 700 unique users across 5 city departments, which included water, environmental and general services, business services, management, and procurement. Some initial considerations with the new EAM was the initial need for a GIS integration to the new EAM. Because our linear assets live in the GIS, we capture data such as mains, valve diameter, pipe material, pipe lengths, install dates for warranties, and we also do asset archiving in the GIS to take our assets out of service so that work orders are not written against them. There was an internal push to use less third-party tools within the city, so we had to complete a full evaluation of the native integration tool. Some initial integration challenges that we faced were that we had to do a lot of manual processes and checks. From 10 layers that we had in the GIS, we had to break them down into subtype, which created 37 layers for us. And for each layer, we had to create between 10 to 20 mappings. 500 records would take 2 to 4 hours. Some succeeded, some did not. We would have to start all over. As our go live date came closer, we were tasked with getting critical assets synced to the EAM. There was no preview mode before commit, so we didn't know exactly how things would look before we pushed over to the EAM. No reporting led to duplicates, orphans, and errors. One example is that we created 300,000 service connections because a GIS ID was not pushed back into the GIS. There was no ability to migrate from one environment to another without having to remap through dev, test, and production. And the tool lives inside of ArcMap, so it makes it tightly coupled to current versions of Esri and HxGN. And if you want to upgrade, you have to wait for a new version of the tool. In the search for a new solution, we previously had a relationship with Geonexus because we used their GeoSync tool with our old EAM, and we knew there was a no-code HxGN EAM connector. We had an upcoming deadline and we're tasked to only sync the critical assets by the project manager. And once go live, we were approved to run a pilot of GIP for the integration between GIS and EAM. Our GIP project goals is that we wanted a seamless integration of GIS and the EAM databases to reduce risks, deficiencies, and redundancies. We wanted to maximize accuracy, integrity, and timeliness of the data between databases for effective data reporting, analytics, and successful data-driven decision-making. Now, Umesh will go over the solution. Umesh?
All right, thanks, Lorena. My name is Umesh Menon. I'm the Vice President of Strategic Product Management at Geonexus. I oversee the product roadmap, development team, and technology partnerships with our various technology partners. I'm excited to be here with Carla and Lorena to talk about this integration initiative. Just a little bit about who we are, Geonexus. We're a software company. We're based in Ann Arbor, Michigan. Been around for about 14 years. We've created an integration platform that supports asset-intensive organizations to create and manage integrations that connect to GIS, CIS, and EAM systems. Our customer base range from North America, UAE, and Australia, and we are a Esri Silver partner as well as a HxGN Alliance partner. So the foundation of our software is solving integration needs where geospatial data is a large component within the organization. What we typically find with customers that come our way is they have a custom developed integration or an EAM integration component that is limited on functionality or performance. This leads to hiccups either from the get-go of the project or ongoing maintenance. So we take a unique approach to integration by providing an out-of-the-box platform that makes it fully supported, simple to set up, and maintain over the course of the integration lifecycle. We call that solution the Geonexus Integration Platform, or GIP for short. We have three core competencies that our platform provides. The first is around simplified configuration. We give our users a set of tools from the user interface to easily configure data sources, mapping rules, and allow you to define those use cases. This makes it not only easy and streamlined to set up the integration, but also to maintain the integration as the use cases evolve and new requirements come up. The second component is automated data synchronization. Once we have the configuration set up, you can schedule GIP to run in the frequency you want, whether that's daily, weekly, monthly, etc. This will then run through the GIP process of extracting the records, doing a full compare of the data, and then determining what needs to change and synchronize per the configuration. And the third component is around active reporting. This is one of the things our customers really appreciate of our solution. There are kind of two levels to this. The first is the readout of what happened during the synchronization, what creates happened, what updates happened, ensure that the automated step is working as intended. And then the second level is around error and issue reporting. So if something fails, you get notified and you get some detail around what happened and why the failure occurred. And all of this goes through our library of connectors. So we've created pre-built connectors that simplify the integration, which is all part of the platform. We're specifically talking about HxGN and Esri today, but we have others. Additionally, we've created a REST API and an RDBMS connector. And this is a way to support integrations for systems that we don't support through our pre-built connectors. This might be homegrown solutions or other commercial solutions that we don't have pictured here, but we could potentially still support those systems. So our application sits outside of the edge systems that we connect to, which makes it a loosely coupled integration. The way we connect to systems is primarily through APIs. For the HxGN EAM system, we connect through web services. For Esri, we have the ability to connect through the geodatabase via ArcGIS or using the Esri REST APIs. This is all handled through a productized connector, so users do not have to develop or have any familiarity with the APIs. Okay, and then how it works. So from a configuration standpoint, when you open our application, you're taken to the GIP user interface. The first thing you're going to do in our application, your beginning configuration, is establish the edge system connections. And this is simply where you put in the connection details and the user login credentials. Next, you're going to configure your data source alignment between your systems. So this could be a particular feature class in GIS to a data spy in HxGN. And then lastly, you configure your mapping rules. So this is done by selecting dropdowns from your source system to your target system. And I'll talk a little bit about the benefits. So first, reducing burden on your IT departments. So you eliminate custom development of these integrations so you can easily manage it all through this platform. Again, our application does not sit in any edge systems, so it allows you to upgrade your edge systems without having to touch the integration. Realize value quickly. The implementation setups are simplified because of the UI and the library of connectors, which allows you to quickly get to production. Data validation. Every time the process runs, you receive a report of what happens. And if there are any errors from the system, those will be provided in the reports. This is out of the box for how the product works. And then lastly, system expertise. This is a fully supported product. We're continuously thinking about how we can enhance it from a usability standpoint, expand the synchronization functionality and the reporting functionality. We target quarterly releases so our users can take advantage of the continuous innovations that we're coming up with. And we also support our customers when they run into issues. They have a way they can reach out to us to open tickets. We also have a knowledge base that enables them to perform self-service if they would like to go that route. I'll pass it over to Carla to talk about the implementation and anticipated benefits.
Thank you, Mish. Some of the benefits in using the GIP tool versus the HxGN tool is as follows. Our work was dramatically reduced. With the GIP tool, we can create a mapping, and within each mapping, there are quite a bit of configuration rules. Instead of manually creating all mappings and rules for all the subtypes, we were able to copy the mapping and rename it and adjust the rules accordingly. We also can copy all mappings and rules and apply it to any instance, whether it be test, train, or prod. With create and update rules in place, we can easily identify any errors or issues. It is fully supported and easy to use. With the GIP tool, we have reports that are written out anytime the tool syncs. Also, it has preview mode. You can add rules, run it in preview mode before committing, so you can review it and see if that's what you really need or not. GIP tool has value lists, which is extremely helpful. With the HxGN tool, we had over 30 mappings, one for each subtype. Having value lists in place, we were able to reduce those mappings to a smaller list. Tucson Water and Geonexus got together to run a pilot project. Our onboarding approach is using incremental introduction. There were 3 data sets that were configured: water mains, gate flow valves, and butterfly flow valves. It included creates and delete rules. We wanted to know if the GIP would meet our needs, and of course it did. Not only did it meet our needs, it exceeded our expectations. Our current implementation tactics was our onboarding approach is using incremental introduction. We had the Geonexus team, Amelia and Shay, come to Tucson to help us. They were here training us for 3 days. We configured 5 data sets with the Geonexus team. We went ahead and prioritized the more complicated data sets. With the training they provided us, we felt comfortable in configuring the remaining data sets independently. The GIS will be managing the GIP tool along with the mappings and configuration rules. GIS and EAM teams will be collaborating with each other to ensure the integrity of the data that is being synced. Some of our future uses is we are in the process of implementing a new CIS billing system for IPS. We would like to use the GIP tools to synchronize address and parcel data and push out addresses from Infor IPS to several services and tables for water, fire, and environmental services. This is just an example of our project. You can see that we created some roles on the right, and on the left, you see all of our feature services. It has a value list, role templates, and you could create and update roles as well. You can see where you put the field in the source and it gets pushed over to the target field. This is an example of the synchronization report. It tells you how long it took. It also breaks the report into sections. So on the left, there's like little hyperlinks that'll, if you click on there, it'll take you to that section. You can see the orphans, creates, any updates or discrepancies, duplicates, etc. And with that, I'll go ahead and turn it over to Lorena, where she'll go ahead and do a demonstration.
So I'll go ahead and get started. GIP is a true middleware. As you can see, it lives in its own server, which is great. Here we're in the UI for GIP already. And if you can see on the left-hand side, I have my project already created. This one is created strictly for this demonstration. What I'm going to do first is I'm going to go ahead and validate my connections. So I'll expand my connections folder and I'll double click on my HxGN connection. Click validate. I can just close this window and double click my geodatabase connection. Validate. Succeeded. Okay, so GIP has a library of connectors, and if I right click on my connections folder, you can see all of the connectors that are available. I only need the HxGN and the geodatabase connection for now. So next, what I want to do is I want to go ahead and configure my data set. I'm going to expand my folder, and there are two ways to create a data set in GIP. You can either right click on data set, start from scratch, or you can right click on an existing data set, copy the data set, rename it, repoint, and just make a few tweaks to the data set. Here, I'm going to go ahead and hit cancel because we already have two data sets created. We have a linking data set, which is a one-time cleanup to create the GIP ID in both the GIS and HxGN. Then we have our create and updates data set, which will run on a nightly basis and create new assets and make any updates to existing features. So my next step is to configure my data sources. I'll expand my data source folder, and I'm going to right click on my HxGN. This data source tells us that we're creating assets, and we must be pointing to an existing data spy in HxGN. My geodatabase data set, we must connect to the corresponding table of the feature class we are creating. If I pull down the dropdown, you'll see that it contains all the tables that the user has access to. We can create a where clause or a definition query. In our case, we only want Tucson Water owned assets with the lifecycle status of active, design, final, and inactive. Once that's done, then what I'm going to do is I'm going to click on the calculated tab down at the bottom. We've created a calculated value for our description field that will be pushed over to HxGN. It's a concatenation of a prefix and some extra attributes from the GIS. Once I'm through with that, I'm going to go ahead and configure my foreign key. I'll go ahead and double click on my water quality sampling create and update dataset. I'm going to click the foreign keys tab. Here I can see that I have my HxGN source and I have my target, which is GIS. And if I do the drop down on the target key, I can see all of the fields that are available to me in the GIS. In this case, I'm creating a GIP ID. Now I'm going to go ahead and click on key generation. And GIP creates a key into the GIS GIP ID field, and a key is also created in HxGN. My key will contain my prefix and will be followed by 7 digits with 0 padding to make a total of 12 characters. I'm going to go ahead and hit save. And I'm ready to create my rules now. So once I expand my synchronization rules folder and my target rules for Hexagon, I'll double click on create rules. Here's where we configure our attribute mappings. We have attributes on the GIS side and the Hexagon side, and we're pushing from GIS to Hexagon. We also have one attribute coming from Hexagon to GIS, which is the EAM ID or asset ID. We must also make sure that all of our mappings are included in the data spy that we originally are pointing to in the Hexagon data source. So here what I'm going to do is all of the default and the calculated source attribute types are going to be pushed over to Hexagon only upon create. Everything else we can go ahead and run on update. So what I'm going to do is I'm going to copy my rules, the rules that I want to be updated on a nightly basis. I'll unselect my default, my calculated, and I'll only keep those field attribute types. I'm going to do the drop down and I'm going to do copy selected. And here I'm going to tell it to move over to my updated rules. Click OK, hit save. If I double click on my updated rules, you see that those are all copied over. Oop, we missed one default. And that's okay because we can check it and just delete it. We can hit save again. Okay, so another component of GIP is that we can create value lists. With value lists, we can push over the correct subtype to the category field in Hexagon or the layer field in Hexagon. This way we only keep the original 10 layers that we work with in GIS, and we won't have to create 37 layers like we have now. We can also create spatial queries. And we've set those up to identify what work area each asset belongs to. So prior to GIP, we would do this manually. Okay, now I'm ready to run GIP in the console. So I'll double click on my console. And actually, before I do that, I want to right click on my water quality sampling, creates an update. Right click, and I'm going to enable my data set. I'm going to hit save. And one of the many benefits of GIP is that you can run your changes and updates in preview mode, so we don't have to commit, and we can get our eyes on what changes we are really making before we commit to them. Now that I've saved, I'm going to go ahead and hit start. So once connected, GIP will start running, and here you can see the progress of GIP and all the phases that it goes through. What I love about GIP is that you can see the percentage complete as it's running. So now that the stop button is grayed out, we know that GIP has finished running. So every time that you run GIP, a report is created. So I'm going to go over to the left-hand side and double click on reports. You'll also get a report by email. I'm going to double click on the very first one. And this report will show you what feature class you are running, how long it took to run, how many features you ran using the GIP. And you don't have to scroll up and down to find, like, the table of contents gives you the number of pages. But if you just right click on the tabs over to the left-hand side, it'll automatically take you to where you want to be. This kind of just gives you a breakdown of the different phases as we talked about earlier while it was running. I see, like, we have an orphan. That orphan was created because we are in preview mode. So once we commit our changes, that orphan will not be there. You can look to see if there were any errors, orphans. If we click on the generated keys tab, we'll see that there was one key generated, my prefix followed by the seven digits. You can see what was created. So from the GIS to Hexagon, You can see the different attributes that were being pushed over. Anything that is empty in the values column just means that there wasn't a value in the GIS to be pushed over. And then if I click on my update tab, I can see all of the assets that were updated and what values went over to HxGN. So with GIP, everything is tracked, and you can use these reports for auditing and finding anomalies, orphans, or just what you did in preview mode before you commit your changes. And in a nutshell, that's GIP. Thank you.
All right, thanks so much, Lorena and Carla and Umesh, for that great presentation. If anybody has questions that they want to submit, we got a few, but keep submitting them if you have any questions. We have the team here to help answer, but I can go ahead and start going through some of them. So the first one is, what is the difference between GIP and the HxGN toolbar? So I can go ahead and answer this one. So some of the key differentiators that both Lorena and Carla pointed out in their presentation of GIP, the first I would say is preview mode. So you just saw in that demo that you can run the tool without actually committing the changes, and you can view the report just as if it would have been run in commit mode and ensure that everything has come over as expected. This is especially helpful during testing phases. So we find that to be a big differentiator and something that's not available in the other tool. The next one would be reporting. So again, as you saw in that demo, every time you run the tool, whether you're in preview or commit mode, you get a report that details everything that was touched during that integration, during that run of the integration. And so this is really helpful for resolving any discrepancies that might be in your data. And then finally, one of the other big differences is the ability that GIP has to handle complex use cases. So this tool was built specifically for integration, and that's all we focus on. So we can handle a lot of unique use cases, especially with the GIS use cases. Lorena or Carla, do you have anything to add to that?
I would say it's a great tool. GIP far exceeds our expectations. The HxGN tool resides inside ArcMap. So like it said in the presentation, it's tightly coupled, and the GIP lives outside, so it's loosely coupled. So that's one thing that we really liked, as well as the reports that get created right after the synchronization, whether it be in preview mode or if you commit, you have those reports. There is a great example that we have. There was one time that someone accidentally deleted a 54-inch water main. And thanks to the report, we were able to go ahead and identify when it was deleted. And so we were able to go ahead and bring that back. So that's very important. And HxGN doesn't do that. So.
Thanks, Carla. That was a great example. All right, the next question here is, what version of HxGN and what versions of Esri do you support with GIP? So with HxGN, we support anything 11.7 and beyond. And then on the Esri side, we support the latest and greatest, and we go back pretty far as well. So we support the Arc Pro and the utility network and can handle a lot of those unique utility network use cases. So yeah. The next one here, I'll see if Carla or Lorena, if you want to answer this one. How difficult was it to get the integration up and running?
I can answer that question. Can you guys hear me okay?
Yep, hear you great.
Okay, so awesome. I would say that with the training that we had from Geonexus, it was pretty much a seamless the integration completed. Like Carlin, then we had an artist Tucson. So it was pretty easy. I mean, I thought it was going to be harder than it was, but it was really seamless.
Thanks, Lorena. You broke up a little bit, but we heard most of that answer.
Yeah, we
right.
didn't have any issues. Like Lorena said, it was pretty seamless. We were able to grab because we had the old synchronization tool from Geonexus, and we were able to use a lot of that when we went ahead and implemented the new GIP tool.
Thanks, Carla. All right, another question. Did you try using the built-in HxGN to GIS connector first? And if so, what issues did you encounter, and did this solve those issues? So did GIP solve those issues?
Yes, we had to use the native tool, the native integration tool, before we could actually go into GIP. A lot of the issues that we had is that, like in the presentation we mentioned, you know, if we were trying to sync 500 records, it could take 2 to 4 hours to sync. Sometimes it would not go through at all, so we'd have to start all over again. It took us 4 months after we went live in August of 2022 to finish our integration using the HxGN tool. The HxGN tool lives inside of ArcMap, so it's very tightly coupled. You can't upgrade versions of ArcMap without first getting a new version of the tool. Sometimes the GIP ID or the GIS ID, the GIS OBJ ID is what connects the two databases. That would not come back to the GIS. So we ended up creating a lot of duplicates in our training environment, which we later learned we needed to have a legacy ID added to, for instance, our service connections. We didn't have them in our old asset management database. And so they didn't have a legacy ID. So when we were seeking those, we didn't know which ones were going through to EAM that were already in the GIS. So we did create over 300,000 duplicate service connections. GIP, yes, that has solved that problem for us. A lot of the things that we did with the HxGN tool is there was a lot of manual work. So as an editor finished a version, whatever assets were created in the GIS, we'd have to manually sync those to the EAM. So that added more time when QCing works and finishing up a job for us. With the GIP, it's pretty, you know, you set it on the task scheduler, it goes through, everything comes back perfectly fine. We could use that preview mode to make sure that everything that's going over to the EAM from the GIS is what we want in the database. So yes, GIP has solved all of those issues for us.
And let me
Thanks,
just
Lorena.
add, sorry, let me just add
Oh, no, go ahead.
to Lorena's comment too as well. Like she said, a lot of stuff was done manual doing the HxGN. And because of the fact that there were times that the GIS OBJID didn't come back to GIS, we would manually go into the HxGN and like export all the records from EAM, and then we'd have to join it to make sure, you know, that what we synced over was in fact true. So there was a lot of like QA QC like that going on with the HxGN tool.
Thanks, Carla. All right, and I think we'll have this be the last one, but feel free to reach out. We have everybody's email addresses up here. If you have further questions, feel free to reach out and ask those. But last one here, based on your experience, what advice would you offer to an organization just getting started with their GIS and HxGN integration? Carla or Lorena, do you want to take that one?
Sure. I think one of the biggest things is just to know what attributes are going to be going from one database to another. Also making sure to do a QC in your GIS and your EAM. I know in our situation, they didn't move everything that we had in the GIS that we were previously syncing. With the new EAM, not all of those feature classes were going over. So but they took everything from the old asset management database and they put it in the new EAM. So now if we are trying to create new things, we may have something in the EAM that we have to make sure that there isn't already an ID created for. Another thing is if you are doing a lot of editing, make sure that your versions are all posted before the integration takes place. Once that integration takes place, then when you do your reconciles, it will create a lot of conflicts for you. That's one of the biggest things that I learned in the project, is making sure that all of those versions are minimal or completely posted so that you don't have that issue. And just, I think a lot of collaboration with your EAM team is a big thing because they know what they want to see in their database. You know what you have in the GIS database, so working together just makes it that much more complete and the data is a lot cleaner.
Well, thanks so much, Lorena and Carla. Yeah, I want to go back to something Lorena hit on, both great advice, but I like how you hit on working together with the two teams. I think that's what we found in projects that we work on. It's always the best when the GIS and the EAM teams are working together, so you can get on the same page. And so that's great advice. All right. Well, I want to thank everyone so much for joining us today, and especially thank you to Lorena and Carla for all your help with this presentation. And it's great working with you. And so thank you so much, everybody. Have a great rest of your day.
Thank you.